Section 3.1, to find the radian measure for angles. In most applications of trig, angles are measured in degrees. In more advanced work in mathematics, radian measure of angles is preferred. Radian measure allows us to treat the trig functions as functions with domains of real numbers rather than angles. This slide shows an angle theta in standard position with a circle of radius r. Here, standard position with radius of r. And we know that this ray is r, and also this ray is r because radius in all circles are congruent. The vertex of theta is at the center of the circle. Because angle theta intercepts an arc on the circle equal in length to the radius of the circle, and here is the intercepted arc, and notice this intercepted arc is equal to the radius of my angle. And if this is true, then we say that angle theta has a measure of 1 radian. And again, it states here, an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of a radian. Now we know that we have angles that can be measured in radians or degrees. So we have to have a way of converting from degrees to radians and back again. So here we have two methods. Multiply a degree measured by pi over 180 radian and simplify to convert to radians. And if we have a radian and want to go to a degree, we multiply a radian measured by 180 over pi and simplify, converting to degrees. Let's look at an example. Here we want to convert from degrees to radians. So we want to keep in mind the previous slide that when we go from degrees to radians, we want to multiply our degree by pi over 180 and then simplify. Our first problem is 60 degrees. 60 times pi over 180, and then all we need to do is to simplify this problem. Here we have 60 into 180. We're going to have pi over 3 radians. What we can do is to convert pi over 3 into a decimal. And by use of the calculator, second, the caret, which is pi, divided by 3 equals 1.047. Example B wants us to convert 221.7 degrees into radians. Again, the same procedure, 221.7 times pi over 180. The problem here is that 60 simplified into 180 evenly. 221.7 over 80 doesn't simplify evenly. So what we'll do is just use the calculator. On the calculator, I have 221.7 divided by 180. That gives us 1.23 pi radians. As in the previous problem, I can convert 1.23 pi into all decimals by just using the calculator, 1.23 times pi, and I get 3.864 radians. Our next slide wants us to convert radians to degrees. Recall from a few slides ago that to do that, we need to multiply our radian measure times 180 over pi. Our first example, 11 pi over 4, just multiply by 180 over pi, and then we simplify. Here, the pi's can cancel out, and then we simplify the fractions. The quickest way to do that is to just use a calculator. 11 times 180, and then divided by 4. And so 11 pi over 4 radians is 495 degrees. Example B, 3.25 radians, we just multiply by 180 over pi, and then we can use a calculator to simplify. Here I've entered 3.25 times 180, I got 585, and then we just divide that answer by pi, and our solution is 186.2 degrees. This chart shows equivalent angles in degrees and radians. I will put this under our group resources for Chapter 3. A quick demonstration, again, from degrees to radians. All they did for each one of these degrees is to multiply by pi over 180 and then simplify the fraction. 30 to 180 gives me 6, and then all they needed to do was use a calculator to take pi divided by 6 to get 0.52 radians. The exact value and the decimal is the approximate value. Then all they need to do is go back from a radian to a degree is to multiply by 180 over pi and then simplify. And the pi's would cancel out. 180 divided by 4 simplifies back to 45 degrees. The previous two slides represented our procedures for going from degrees to radians for the exact value and the approximate, and also going from radians back to degrees. This next slide shows another diagram that shows equivalent angles in degree and radian measure. The procedure to get a degree to a radian and a radian to a degree is the same procedure as we have done on the previous slides. To go from 30 degrees to pi over 6, we would just take 30 degrees and multiply that by pi over 180 and simplify. 30 goes into 180, 6 times I get pi over 6. Similar to this situation, to go from 5 pi over 6 to 150, I would just multiply 5 pi over 6 times 180 over pi, and then simplify. The pi's would cancel out. 180 divided by 6 is 30. 30 times 5 is 150 degrees. You can follow the same procedure to convert each of the other angles, but we've done that several times. I've put this diagram on the group resources under Chapter 3. This next slide gives us a couple of examples of how the previous procedure of converting radians to degree and degree to radians can help us solve for trig values. Here, these problems ask us to find each function value. The first problem gives us tan of 4 pi over 3. We can find the value of tangent if I actually know the degree, but in this situation they give us a radian value. But I can convert the radians, which is 4 pi over 3, into a degree by multiplying by 180 over pi. I can then simplify this to get 240 degrees. So now what I'm solving for is the tangent of 240 degrees. Let's sketch this angle in a coordinate plane. 240 degrees will put us into quadrant 3. Now I want to find a reference angle, and to do that all I'm going to do is take 240 minus 180, which will give us a 60-degree angle. And now we find the tangent of 60 degrees, but this has to be in quadrant 3. Recall from Chapter 2 resources, we have a function value of special angle chart, and here we see 60 degrees, and that will be tangent, and that gives us a value of the square root of 3. So going back to the problem, we know that the tangent of 60 degrees is going to be the square root of 3. Now we need to determine, is this positive or negative? We also know that tangent is the value of y over x. And in quadrant 3, x is negative and y is negative. So a negative divided by a negative is positive, the positive square root of 3. Our next example, sine 4 pi over 3. From the previous problem, we've already converted 4 pi over 3 radians by multiplying by 180 over pi and got 240 degrees. So we're going to find the sine of 240 degrees. But from the previous problem, we've also found that this is in quadrant 3 and the reference angle is 60 degrees. So this is actually the sine of 60 degrees. And from the chart in our group resources under Chapter 2, shows us function values of special angles. We have the sine of a 60-degree angle is the square root of 3 over 2. Going back to the problem, we know the solution is the square root of 3 over 2, but we have to determine, is this positive or negative? in quadrant 3 where 240 degrees is located. We've already done some of the work here that we know that sine is y over r. And in quadrant 3, y is negative and r is always positive. So a negative divided by a positive is going to give us a negative square root of 3 over 2 for the solution.